The material that I was interested in exploring was aspartame. Aspartame is a synthetic sweetener and sugar replacement. Products that include aspartame are carbonated beverages such as Diet Coke, desserts, iced tea, chewing gum, and so on. So the history of aspartame. It was discovered in 1965 by James M. Schlater. He was a scientist working for the G.D. Sirloin Company. He was working on a project to discover new treatments for gastro ulcers. He actually discovered it by accident when he had some of it on his fingers, licked it, and noticed the sweet taste. He further tested the chemicals in black coffee, noticing the sweet taste. This led to further development of the production of aspartame. So the structure of aspartame. Aspartame is synthesized via 3 smaller macromolecules. In the chemical synthesis, the 2 carboxyl groups of the aspartic acid are joined into an anhydride. Aspartame is the methyl ester of the dipeptide of the aspartic acid and phenylalanine. Under strongly acidic and alkaline conditions, it bonds methanol by hydrolysis. This creates the large aspartame molecule structure. Intermolecular forces. The chemical formula is carbon-14, hydrogen-18, nitrogen-2, oxygen-5. Aspartame has 2 linkages, the amine linkage and the ester linkage. The melting point is about 246.5 degrees Celsius, and it decomposes at boiling. So how does it actually work? Well, like all sweetnesses, it is detected through the sweet taste receptors on the tongue. These are the heterodimeric G protein coupled receptors comprised of the taste receptor 2 and taste receptor 3. They bind sugar, small molecules, sweeteners, and sweet proteins to multiple binding sites. Aspartame you see binds in the venous flytrap module of the taste receptor 2. As well as aspartame is 200 times sweeter than sugar, so it's way more potent. So what exactly are the benefits to society? Well, you see, aspartame is a perfect weight control. This is because the low calorie intake allows you to not sacrifice taste and use pleasure. Because unlike sugar, you need way less aspartame to deliver the same sweetness, so it's way less calories. It also enhances instant flavors. It has a clean, sugar-like taste, so it enhances fruit and citrus flavors in foods and beverages. It's also helpful for people living with diabetes. Aspartame allows those with diabetes to satisfy the cravings for sweets without raising blood sugar. It also helps prevent tooth decay. A study from the American Dental Association says that low-calorie sweeteners like aspartame don't promote tooth decay. So what exactly is its impact on the environment? Studies are being conducted regarding environmental behavior of the chemical and water sources. Human bodies, you see, are not able to convert artificial sweeteners into fat, therefore they pass right through us. Water containing artificial sweeteners can harm plants' ability to perform photosynthesis, and water treatment plants have a hard time removing the extruded fake sugars, as well as new legislation has now classified it as a hazard to the water body. So there it is. That concludes my talk on aspartame, and I hope you came away learning something new.